Hello everyone. In this video lesson 7, we will continue our discussion about set relations and set operations. By the way, don't forget to subscribe the channel and also turn on the notification bell so that you won't miss the upcoming lessons. So let's continue. The first relationship between sets we have is the subset, and this is the symbol of subset. A is a subset of B if only if for all x, x an element of A implies x an element of B. That means all elements in A are also elements in B. In that case, we say A is a subset of B. This is the way we describe subset based on logical concept. In other words, all elements of A are also elements of B. Now let's take example. Considering set A containing 6 elements and set B, which is described based on set builder method, x says that x is a factor of what? 80. So if you consider the elements of A, for all x, if x is an element of A, then x is a factor of what? 18. 1 is a factor of 18, 2 is a factor of 18. All are what? Factors of 18. Because of that, we can relate these two sets based on what? Subset. So we can say A is a subset of what? B. And the other concept regarding the subset, just for any set, M set is a subset of A, because M set is a subset of what? Every set. M set is a subset of what? Every set. Because if you say M set is not a subset of every set, it will contradict the definition of empty set. Because of that, by default, empty set is a subset of any set, and any set is a subset of itself. So this is the first relation we have between two sets. Now the second relation, you can relate two sets based on equal. A is equals to B if only if for all x, x in A implies x in B. At the same time, x in B implies x in A. We combine these two based on what? By implication. That means both A and B contains what? Exactly the same elements. When they contain exactly the same elements, just we can say A is equals to B. Again, if you take the similar example, set A containing 1, 2, 3, 6, 9, 18. Set B, x says that x is a non-negative factor of 80. In this case, we consider non-negative. So, the only difference between these two sets is the description. We describe set A based on complete listing method. We list all the elements. We describe set B based on what? The set builder method. Both will have what? The same elements. That means they contain exactly the same elements. So A is equals to what? B. And also A is equals to B if only if A is a subset of B and B is a subset of what? A. Because for all x, x an element of A implies x an element of B means A is a subset of B. At the same time, the second implication from right to left, if x is an element of A implies x an element of B, then B is a subset of what? A. So when A is a subset of B and B is a subset of A, then the two sets are what? Equal set, because they will contain exactly the same element. Now the third relation we have is the equivalent. This is the symbol of equivalent. Now set A is equivalent to set B if only if there is a one-to-one correspondence among their elements. Now in case of equivalent, we consider number of elements. If both contains equal number of elements, then the two sets are what? Equivalent sets. Now if we take the same example, set A containing 6 elements, set B, x says that x is a negative factor of 18. These two contains what? Equal number of elements. So you can say A is equivalent to what? B. So in general, A is equivalent to B if only if the number of elements of A equals to the number of elements of set B. Now the fourth relation is the proper subset. This is the symbol of proper subset. A is a proper subset of B if only if for all x, x in A implies x in B. That means all elements of A are what? Elements of B, and this is conjunction, and A is different from what? B. All elements in A are what? In B, but B is different from A. B is different from A means there must exist at least one extra element in B, but not in A. Or A has at least one element that is not in set A. So in that case, we say what? A is a proper subset of B. So the difference between subset and proper subset, in case of proper subset, all elements of A are in B and B is different from A. But here, for subset, all elements in A are what? In B, and A and B can be what? Equal sets. But for the proper subset, B must be different from what? Set A. That means there must exist at least one element in B which is not in A to say A is a proper subset of B. Now let's take example. Set A, the same 6 elements. Set B, 1 up to 20. So A is a subset of what? B. Because for all x, x in A implies x in B. And there is what? Extra element in B which are not in A. So we can say A is a proper subset of what? B. So these are the basic relationship between two sets. In addition to relationship between two sets, it is possible to determine the number of subsets and the number of proper subsets of the given set. For a finite set A with number of elements is equals to k, if set A contains k number of elements, then we expect to the power of k number of subsets, and to the power of k minus 1 number of proper subset of the given set A. The reason we subtract 1 is because any set is not a proper subset of itself. So we subtract 1 from to the power of k. So based on this, you can determine the number of subsets of a given set and the number of proper subsets of the given set. Once we know how to relate two sets based on the concept of subset, equal set, equivalent set, and proper subset, the next point is the definition of the power set of a set. Now, the power set of a set A is the set of all subsets of set A, which is denoted by P of A. Power set of set A is a set by itself which contains set B when B is a subset of what? A. So it is a set which contains sets as an element, and these sets are a subset of the given set A. Now, to understand this definition, let's take a particular example. Considering set A containing minus 1, 0, 1. So we have 3 elements for A, and we expect to the power of 3, 8 subsets. So a set that contains all these 8 subsets as an element, we call it the power set of set A. The 8 subsets of set A, the first one is what? Empty set, because empty set is a subset of every set. A set containing minus 1, a set containing 0. All these are what? Subsets of the given set A. Even the set itself, any set is a subset of itself. So total we have what? 8 subsets. So a set that contains all these 8 subsets as an element, we call it power set of the given set. The number of elements of the power set of set A will be what? To the power of 3, which is 8. So given a set, we can determine the total number of subsets. Now, once we know how to determine the total number of subsets of a set, we can find the power set. Now, let's take additional example so that you understand how to find the total number of subsets and the total number of proper subsets. So given a set A containing real numbers where x squared minus 1 is equals to 0, now this open statement will be true when x is what, plus or minus 1. So A contains what, 2 elements, minus 1 and 1. The only real numbers that makes this equation true. And B contains what, 3 elements. So the question is, find the number of subsets and proper subsets of set A and set B. It is not that much difficult. Once you determine the number of elements of the set, A contains how many elements? 2. B contains 3. So for A, we expect to the power of 2, 4 subset, and 2 to the power of 2 minus 1, 3 proper subset. For B, to the power of 3, we expect 8 subsets, and 8 minus 1, 7 proper subsets. So the power set of set A will contain 4 elements. The power set of set B will contain 8 elements, where the elements are what? Subsets of the given sets. Now the last remark regarding the relationship is, if two sets A and B are equivalent, then they need not be equal. That means equivalency doesn't necessarily imply equality, but equality implies equivalence. If two sets A and B are equal, then for sure they are what? Equivalent. So these two are important remarks regarding the relationship between what? Sets. So if you have any question, don't hesitate to write it on the comment. I'll be very glad to explain the concept that you are having difficulty with. Okay, next to set relation, we'll see about set operations. Now the first operation we have is the union. Just A union B contains X when X is an element of A or X is an element of what? B. Just we are combining based on disjunction. If one of the two true or both true, then X will be an element of what? A union B. That means the union of two sets A and B is the set of all elements which belongs to either A or B or to both A and B. Now let's take example. Considering set A, real number where the real number square is equals to 9. So set A contains plus or minus 3, and set B contains 1, 3. So A union B will contain what? Minus 3, 1, and 3. You can easily get the union of two sets. A intersection B is a set containing X, where X is an element of A and X is an element of what? B. So in case of intersection, we are using conjunction. For conjunction, both must be what? True. Both must be true means the intersection set will contain elements which belongs to both set A and set B. So A intersection B is the set of all elements that belongs to both A and what? B. Again, if you take set A integer where x squared less than 9, less than or equals to 9, and set B containing integer greater than 0, then the intersection of these two sets will be 1, 2, 3, because set A contains integers from minus 3 up to what? 3, because the square will be what? Less than or equals to 9. These are integers which makes the first open preposition true. Now integers greater than 0, 1, 2, 3 up to what? Positive infinity. So the common elements are what? 1, 2, 3. So A intersection B contains 1, 2, 3. Now the other important point regarding the intersection, if the intersection of two sets is empty, then we call the two sets are what? Disjoint sets. Disjoint sets are sets with no common element. And the absolute complement of a set A is denoted by A prime, and A prime contains X, where X is an element of U and X is not an element of what? A. All elements in the universal set but not in set A, we call it the absolute complement of what? Set A. And the relative complement of set B with respect to set A, which is denoted by A without B, A without B, elements in A but not in B. X an element of A and X is not an element of what? B. That means A without B contains what? Elements belongs to A but not in B. That's what we mean, the relative complement of set B with respect to set A without B. So considering a universal set containing all English alphabet A up to Z, let set A contains vowels and A complement will be what? Consonant. Because A contains vowels in English alphabet, so the complement means English alphabet which are not a vowel will be what? A consonant. And again, for relative complement, you can consider these two, set A and set B. Now A without B will contain what? Elements only in A but not in B. Only in A but not in B. So -1 and 0, these are the two elements which lies only in what? A but not in B. At the same time, B without A, the relative complement of A with respect to B contains what? 2, 3, 4. Set B without A. Set B without A, elements only in B but not in A are what? 2, 3, 4. So based on this definition, you can find the absolute complement. When we find absolute complement of a set, yes, we compare a set with the universal set. But for the relative complement, we are finding the relative complement of set B with respect to set A, or the relative complement of set A with respect to set B. Now the other important remark regarding the complement, given any two sets A and B, the double complements of a set is the set itself. That means the complement of A complement will be what? A. And the union of A complement with A will give us what? The universal set, because A complement means all elements which are in the universal set but not in set A. Union with elements in A, it will give you what? The universal set. And from the definition, A complement and A, they are what? Disjoint sets, so their intersection is what? MPT. Now if you have two disjoint sets, then the relative complement of A, the relative complement of A with respect to B will be B. The relative complement of B with respect to A will be what? A. Or in other words, A without B will be what? A. Because they are what? Disjoint sets. B without A will be what? Set B itself. Because they are what? Disjoint. Now to understand this concept, let's take a particular example. Now consider the universal set, the set of all first year students in Ethiopian Defense University. And set A, the set of all female first year students in the same university. And B, the set of all male first year students. So set A and B are what? Disjoint sets. A intersection B will be what? MPT sets. Now, if you take double complement of set A, now the first complement of set A will give us what? B. And the complement of B will give you what? A. Always the double complement of a set is the set itself. Now, if you take the union between A and B, it will give us what? The set of all female first year students union with the set of all male first year students the union will give us what? The set of all first year students. So A complement is B. B union A will give us what? All first year students in Ethiopian Defense University. A intersection B is what? MPT set. So A without B is what? The set of all female first year students, which is A. B without A will be what? The set of male first year students. A complement means all first year students which are not what? Female. So this will be the same as what? B. So regarding the operation, we have the union, intersection, and the complement. The absolute complement or what? The relative complement, and try to remember these properties. Later on, we will see these properties in different application problems. Now the symmetric difference of two sets A and B, denoted by size symbol, A symmetric difference with B equals to A without B union B without A. Once we know how to find the relative complement of two sets, we can find the symmetric difference. A symmetric difference with B will be the union of the relative complement of the two sets, or A union B without A intersection. Let's take example so that you understand the concept. Consider set A integers where x squared less than or equals to 10, and B natural numbers between 1 and 4, including 1 and including 4, and C natural numbers which are odd and less than or equals to 7. So A, B, C are described based on what? Set builder method. So to understand the set, let's list the elements of A, B, C using roster method. A contains -3 up to 3, the square less than or equals to 10. And B contains natural numbers between 1 and 4, including 1 and 4. And natural number which are odd, less than or equals to 7, 1, 3, 5, 7. So once we have A, B, C, A without B will be what? Elements only in A but not in B. -3, -2, -1, 0. Only in A but not in B. B without A, 4. So the union of these two will be what? The symmetric difference. A symmetric difference with B will be what? A without B union B without A. At the same time, we can take the relative complement of C with respect to A without C, elements in A but not in C, -3, -2, -1, 0, 2, elements in C but not in A, only 5 and 7. So the union of these two will give us what? The symmetric difference between set A and set C. And comparing set B and C, B without C, you can see it. B without C will be what? 2 and 4. 2 and 4 lies in B but not in C. C without B, 5 and 7 lies in C but not in B. The union of these two will give us what? The symmetric difference of set B and set C. So in such a way, based on the relative difference of two sets, we can find the symmetric difference. Now the other properties regarding the complement is the De Morgan's law, which is A union B complement will be equal to A complement intersection B complement. You remember, we have De Morgan's law in prepositional logic. Here also we have the De Morgan's law. A union B complement will be A complement intersection B complement. A intersection B complement, the intersection complement will be equals to A complement union B complement. These two we call them De Morgan's law. And the relative complements can be written in this form. A without B is the same as A intersection B complement. These are important properties. When we simplify set operations, most of the time we use the De Morgan's law and these two important properties of complement. B without A, elements only in B but not in A, is the same as B intersection A complement. So don't forget these properties. We will use it in the near future. Plus, for two finite sets regarding the number of elements, the number of elements of the union of the two sets will be n of A plus n of B minus the number of elements of the intersection of the two sets for two finite sets. Again, for three finite sets A, B, C, the number of elements of A union B union C will be equal to the number of elements of A plus number of elements of B plus and number of elements of C minus the number of elements of the intersection of the two sets, and finally plus the number of elements of the intersection of the three sets. Now regarding the cardinality of the union of two sets, we use the first formula, and for three sets we use the second formula. So based on the concept we discussed so far, let's try to solve the following exercises 1 up to 3. Just find the number of elements of a set if it has. For exercise 4 up to 8, just try to prove each property. So make sure you answer each and every question in this exercise. So as usual, if you have any problem, just drop it in the comment section. I'll be very happy to help you and I'll give you the correct answer. And again, don't forget to subscribe my channel and turn on the notification bell so that you won't miss the upcoming lessons. Thank you and goodbye.